Hello everyone. In this video, we will learn about the deadlock detection. Deadlock detection. If a system does not employ either a deadlock prevention or a deadlock avoidance scheme, then a deadlock situation will occur. In this environment, the system may provide some algorithm that examines the state of the system to determine whether a deadlock has occurred and an algorithm to recover from the deadlock. Single instance of each resource type. We need to maintain wait for graph. It's a variant of resource allocation graph. Here nodes will be the processes Pi to Pj. If Pi is waiting for Pj to release R that Pi needs. This is a wait for graph. So Pi Pj will exist if and only if the resource allocation graph contains two edges. That is Pi is in need of, makes a request to the resource, and that resource is currently allocated to the process Pj. If this condition is there, means we can use this kind of a representation. This is a resource allocation graph. Now for this resource allocation graph, in case if we want to represent the wait for graph, the corresponding wait for graph is this. For example, P1 is requesting for resource R1, that R1 is assigned to P2. So from P1 you can draw an edge to P2. Likewise, P2 is in need of R4, but R4 is assigned to P3, process P3. So from P2 you can draw an edge to P3. So likewise, when we are representing this particular condition to the resource allocation graph, we will be getting the corresponding wait for graph. So in a single instance of each resource type, the system has to maintain this wait for graph. So deadlock exists if and only if this wait for graph contains a cycle. This is for single instance. In case several instances of a resource type are available, there are some kind of data structures used to find it out. Available, this indicates the number of available resources of each type. Allocation is a n cross m matrix which defines the number of resources of each type currently allocated to each process. Request is a n cross m matrix indicates the current request of each process. That is, if request of I is equal to k, then process Pi is requesting k more instances of resource type Rj. The deduction algorithm. Let work and finish be vectors of length m and n respectively. We need to initialize work is equal to available. For the various values of I, 1 to n, if allocation is not equal to 0, then finish of I is equal to false. Otherwise, finish of I is equal to true. The idea is if the process has completed, obviously it must have returned the resources allocated. So checking for the allocation, if it is not equal to 0, then finish of I is false. We need to find an index I such that finish of I is false. Also, the request is less than or equal to work. And work is equal to work plus allocation, and we are changing finish of I as true. We are going to the second step. We are repeating it. In case in the second step, if we are not able to find such I value, we need to go to step 4. In step 4, if finish of I is false for some I, then the system is in a deadlock state. Moreover, if finish of I is equal to false, then P of I is said to be in a deadlock state. In this video, we have learnt about the deadlock detection algorithm. Thank you.